thing. Okay, so the first sentence says the radius of this sphere is increasing at a constant rate. At a constant rate means it's increasing at the same rate. It's not increasing and stopping. It keeps increasing at that rate. Okay, of 2 meters per second. Okay, so that's the radius is increasing. That's a rate. Okay, so for rate, we're going to say dr dt. It's increasing, so it's positive 2. At the instant when the radius is 5 meters, okay, what is the rate of change of the volume? Okay, that's another rate, so it's dv dt. That's the question mark, right? Okay, so we know rate of change of the radius, we know the radius, and we need to figure out what dv dt is. Now, they didn't ask us this, but just in case they do later, do we know what that is? Volume? Yeah, there you go. Probably wouldn't be a bad idea to plug it into the formula to get that, because we might need it down the road. Okay, it's good to have everything listed beforehand so that if you do need it, you can use it. Okay, so let's see, 5 cubed is 125, so 125, so it would be 4/3 pi times 5 cubed. So that's 4/3 pi times 125. Let's see, does 3 go into 125? Nope, not evenly. Okay, so 125 times 4, I believe, is 600. Times 4 is 500. So 500 pi over 3. It's about 166 and 2/3. About 166 and 2/3. But I'm going to leave it like that until the very end. I'm not going to change anything to a decimal, because as soon as you start rounding, then your answer kind of becomes compromised. We don't want to round until the very end. It says round your answer, right? At the end, it says round your answer to 3 decimal places. We're going to round, but anytime you have to round, you don't want to do it at the beginning, because you're going to use those numbers and you want to round at the end. Okay, so it's always good to do it that way for the more accurate answer. Okay, so that's everything we know. That's everything we need to know. Okay, that's step 1 and step 2. Okay, step 3. What is a equation or formula that's going to relate what I have here with what I need to find with this guy over here? What's something that's going to relate everything to it? Yep. Absolutely. Thanks. Okay. That's what it's going to be. And luckily they gave it to us. Good. So let's write it down here. Volume equals 4/3 pi r cubed. Okay, that's step 3. Step 4, we don't have to do step 4. We'll do step 4 later today. Step 5, find the derivative of that guy. Okay, so how am I going to have to use, I have a lot of things multiplying, right? I have a lot of things being multiplied. Am I going to have to use product rule for this one? Yes or no? Yeah, not this one, because there's one variable over here, but that's on this side, and there's one variable over here. Okay, pi, remember, is not a variable, so I don't need to do quotient rule or um, product rule. Okay. Okay, so dv dt, I'm going to move the 3 in the front. So when I move the 3 in the front, it's actually going to cancel out with that 3 there. Okay, so it's just going to be 4 pi r squared, and then dr dt. Okay. Last step, plug in. So do that right now. Plug it in, get your answer. Four pi. Okay, so square it, multiply it times 2, multiply it times 4, you get 200 pi. Okay, so if they want you to put the answer as a decimal, then you, in your calculator, you get 200 times pi, and you can get that number. But that's a reasonable answer as well. Okay, so the only thing I got to do is now I have to label that. What units go with this guy? What units are going to go with my answer? Good. It's going to be cubed, right? It's definitely going to be cubed since it's volume, and it's a rate, so it's got to be per something, right? And we're meters per second. Good. So it's going to be meters cubed per second. Okay. Okay, so if you go and look, you got area of a circle. The next one's area of a circle, right? And then the last one is height of a cylinder, right? They're all essentially the same type of problem. They're just different shapes. Some are 2-dimensional, some are 3-dimensional, but they're exactly the same everything, okay? So if we have time, we'll come back to this, but I want to go to the ones from that I gave you yesterday. The 3 problems there, I want to do those because those, we got to use step 4, okay? Let's see. Let me find mine. I didn't upload it. Okay. Okay. Give me 1 second to upload my notes so I can see them. Okay, so for number 1, we're going to start on number 1, whatever the first example is. So first example, do your steps. Do your steps. Step 1, step 2. What do you know? What do you need to know? It's going to be the same, excuse me, it's going to be the same step 1 and step 2. Okay, it's going to be the same step 1 and step 2 until I can get my notes here. So list everything you know, list what the question is asking. But that's the question mark thing. While I get mine up. So for area, we'll do big A 9 pi. Good. What else do we know? Mm-hmm. So the rate of the area is decreasing. Good. So what are we going to use? So that's going to be negative 135, right? What are we going to use to denote that on the other side? There you go. Good. Okay. What else do I know, or what else do I need to know? What am I trying to solve with this question? Good, circumference, right? I'm trying to solve for circumference. So yeah, we'll use this T for that. That's what I'm trying to find, okay? So this kind of question is different. Why? How is this question different besides being a circle? Because the next one we were going to do on the first set of notes was a circle. So how is this question different than the ones we did on the first set? Is it not? Can you guys do it on your own? You don't need me? How is it different? Maybe it's not different. Do it. Do it. See if you guys can do it. Because if it's not different, it's just another the same type of question, right? So do the next step. Do step 3. Keep going. Because if it is different, tell me how it's different, and I'll help you out. But if it's not different, try this one on your own. Do it. Or just stare at the paper. Help me out. I can help out, but you got to tell me why it's different. Because if it's not different, you guys should know how to do it, right? How is it different? So they've given us the rate of change of area. So we're dealing with area, right? Instead of volume, we did volume, but that's not necessarily different. It's just because, right? Area formula is pi r squared. Most of you guys probably knew that. That's not different though. That's still the same, right? How is it different? Yeah.
Asking for the rate of change of circumference.
Yeah. And what's different, and I'll give you circumference too. Circumference is the distance around, right? Circumference is it's perimeter, right? It's perimeter but for a circle. So if I started here and I walked all the way around this circle, how far would I walk? That's circumference, okay? So circumference is 2 pi r. 2 pi r. Okay. So how is this different? Mhm. There you go. We're missing something, right? There is no r here, right? R is kind of important. They both have r, right? R squared and regular r, but we don't have r. We don't have dr dt. We don't have any of that stuff, right? We're going to need that, right? What is the rate of change? And we're going to need dr dt. Those are kind of important because look down the way. See the next 2-3 steps. We're going to have to find a derivative, right? And then we're going to have to plug in. Well, it doesn't matter which one we use. We use A or we use C. When you find the derivative, there's going to be a dr dt. There's going to be a r, right? And we don't have that. So my question is, how do we find it? How do we find r? Huh? That's a good way to do it. Yeah, let's do that. We have area, right? We know area is 9 pi. And we know pi and then we need to find what r is, right? So we have enough information where we could solve for r, right? Divide by pi. What's r going to equal? 3, yeah, positive 3, right? It's r is a length, so it has to be positive. So par is positive 3, right? Okay, done there. Which formula are we going to use? So now we're going to step 3, right? Step 3. See if I have it in these. Yep. Step 3. Okay, we did 1 and 2. Now we need an equation that relates everything and solves our question. So which one is that going to be? C, right? C, because isn't the question regarding circumference? So that's the one we're going to use, okay? So we haven't used step 4 anymore. So let's skip it. Let's go to 5. So I want you to find the derivative of circumference. Find the derivative of circumference. Find the derivative of circumference. You guys just did it. Don't wait for me to do it. Do it on your own. If you get it wrong, you have an eraser on the other end of your pencil. You can erase. Okay? Okay, so it'd be dc dt, right? There's only one variable on this side. That's r. And it's r to the first power. So that goes away. So it's just 2 pi dr dt, right? 2 pi dr dt. Okay? Plug it in. What do you get? Mhm. Why not? What's the problem here? Yeah, we don't have two things, right? We don't have dc dt. dc dt we don't have, but we weren't supposed to have that. That's what the question is asking, right? So that one makes sense. I don't have this guy here. That's a problem, right? I can't have two variables and solve for one of them, right? This is a special case. This is why step 4 is there. We've never seen this case before. So we're going to have to use the other equation to solve for dr dt. So what's the other equation that we have? Area. So we're going to have to find dr dt in that one, because that one's going to have a dr dt. Okay. So area, let me get another paper here. Area equals pi r squared, right? That one doesn't have a dr dt, but if I find the derivative of it, it will. Move the 2 in the front, r dr dt. This is not going to help me solve my question, right? It has nothing to do with circumference, but I need to do it. I need to use the second equation because it's going to help me find what I'm missing, dr dt. So I'm going to plug in my numbers here. I know what dA dt is, right? Negative 135. What is that one? Oops. Okay, so plug it in and see what dr dt is. Plug it in and see what dr dt is. Don't wait for me. We made a list. Use the list. Okay, so 2, negative 135 was dA dt. 3 was r. Everything else we had except for dr dt. So all I got to do is divide by 6 pi. There you go. That's dr dt. Leave it like that. Don't change it to a decimal. Not until the very, very, very end. We'll change it to a decimal. Okay? So that number could actually go on our list. Dr dt, negative 135 over 6 pi. Okay. Now let's plug in to our original because we have everything now. 2 times pi times dr dt, which is negative 135 over 6 pi. Okay, there's a little lag there, so it's not going to show yet. I don't know. Okay, finish it out. What do you get? Okay, so you get negative 135 over 3. Negative 135 over 3, which as a fraction is actually the whole number, isn't it? Negative, what is it? 45? Okay, good. How do I label it? How do I label that? So it's decreasing because it can't be, it's not a length because it can't have a negative length, right? So it's a rate. So it's going to be per second, I believe, per second. And then we have feet. So is it going to be feet, feet squared, or feet cubed? Which one of those is it going to be? Just feet. Yep, just feet. Good. Because it's a length. It's not an area. It's not a volume. It's just length, right? Okay. Okay, so I want you to do the next one. Try the next one on your own. It's one of those special case type of things. I'll give you the equation. So it's going to ask you two things. Volume of a cube. Does anyone know what volume of a cube is? Yeah, length times width times height. And what's true about all of those on a cube? They're all the same. Yeah, they're all the same. So side cubed. So if you know one side, it's just side cubed, right? Length times width times height. But on a cube, they're all the same. Okay. And then it talks about surface area. Surface area, I'll give you right now. Surface area is just to cover all the sides, right? If I wanted surface area, like surface area of this box, would be cover this side, it's area of each face. It's area of each face, right? So if I wanted to paint it, this, how much paint would I need? I'd paint this side, I'd paint this side, I'd paint that side, I'd paint that side, right? Surface area has nothing to do with the inside, right? It's just the face, areas of all the faces. Okay, let me get you that formula. It's 6s squared, 6 times s squared. S squared is the area of one side, multiplied by 6. Multiplied by 6. Okay? All right, so do it. Let's see if you guys can do it here. It's a different shape, but it's the same idea. Okay? I'll give you about 5-7 minutes to see step 1, step 2, step 3. I'll give you a hint. You are going to use step 4. You're going to use both of those. Okay? Okay, so if you're still working on it, that's cool. I just want to go over this, start going over this. Okay, so we have the 2, right? Volume is side cubed. Surface area 6 times side squared. Those are the 2. Okay. What's listed? They give us volume is increasing, 88. They say that a side, at that moment, side is 2. The question is asking about surface area. So what's the rate that surface area is increasing or decreasing? Okay. Originally, they don't give us this. Originally, this is a question mark here. They don't give us ds dt, but I had to figure it out. So originally what I did was I went right to surface area, and I was like, surface area is where I need to go because that's where the question is asking. It's asking about surface area. So I found the derivative. dSA over dt equals 12s ds dt, right? And I plugged in dA, the first part right here, dSA over t. I don't know. That's what the question is asking. And I know side, but the problem is I didn't know this guy here. I didn't know ds dt. They didn't tell me, and I didn't know. So I had to go back to the first equation to figure that out. I had to go back to the first formula they gave us, which was volume. Now, volume doesn't have anything to do with my question, the question it's asking me, but I needed it to do that. Okay. So This is how I did it. Okay. So my answer is going to be just a little bit off. Let me change this. So it's going to be 12. 12. 12 doesn't go in evenly, but I can reduce it by 4, I think. 22 thirds. Is that right? Okay. All right. So that gives me ds dt. 22 thirds. Okay. Now I have enough information where I can go and solve for what I originally wanted to solve for. Okay. So when I do that, let's see, 12 goes into 3 4 times. And I'm going to get 8 times 22, or 44 times 4. Let's see. Is 176. How do I label that? It's a rate, so it's going to be seconds per second. What is it going to be, though? Meters squared. Good. Because it's a area. Okay. All right. So I want you to try the next one. Try number 3. Try number 3 on your own. It's volume of a sphere again. Volume and surface area of a sphere. And they give you both equations. Okay. Try this one. Last one. Everything I have listed here is what I know and what I don't know. Okay. Volume is going down by negative 131. Radius is 2. ds, dsa, dt, that's what I need to know. I don't know that. Okay, that's what the question is asking. Okay. dr dt is not anywhere listed, but I know I'm going to need that. So that's not necessarily going to answer the question, but it is a necessary piece. So I'm going to start with what they want. They want surface area. The question is, what is the rate of change of surface area? So I'm going to find the derivative of surface area. So the derivative of surface area is 8 pi r dr dt. And I run into the problem that I figured I was going to run into, where this is a variable, I don't know what that is. This is a variable, I don't know what that is, right? So I can't have two variables and solve the problem. I know what r is 2, but I don't know what this guy is. So how am I going to alleviate that? I have to use the other one, the other formula they gave me, which is volume. So the formula for volume, or the derivative of the formula, is this. Okay. So I know dv dt, negative 131, 4 pi, I know what r is, 2 squared, and I don't know what dr dt is, so I can solve for it. Okay, so I get negative 131 equals 16 pi dr dt. Divide by 16 pi. And I don't believe those guys can be reduced. I think 131 is prime. Yeah. So go over here, negative 131 over 16 pi. Now I can plug it in here. Pi's cancel out. 8 times 2 is 16, so that's going to cancel out with that 16, nice and neat. So I'm just going to end up with negative 131. It's surface area again, right? It's surface area. It's the rate of surface area. So it's going to be per second, yes. And then it's going to be feet squared again, just like it was on the last one. Okay, that's as hard as they're going to get. That's as hard as they're going to get when you have to bring in the second equation. Okay, if you don't have to bring in the second equation, you just use the first equation like we did on the first set of notes. Okay, but that's, if you have to bring in a second equation, that's as hard as they're going to get. Okay, all righty. Okay, so I'm going to post the assignment. We got one more lesson to do, which we'll do tomorrow. Okay, and then we'll do a day of review. Okay, and we'll go from there. All right.